Okay, here's one for the books. This Stromberg Carlson radio is really got issues. And I want to kind of document them for the owner, but also to show you all. And if you got any ideas or suggestions, you can post them in the comments. I'd appreciate it, and we'll see what we can figure out. I've got the camera on a tripod for the first part of this demonstration, and then we will take the camera off the tripod and kind of look at the schematic and other things. Right now I have my current limiting variac dim bulb system set to 110 volts. The schematic, the voltages on the schematic were taken at 120 volts. This is a pre-1940 radio. It has AM and shortwave, and it's super heterodyne. It is a transformer set because, again, it's pre-1940. It's got some peculiarities in its design, but basically it's pretty straightforward. It's not a very complicated radio. Has been recapped, obviously, you can see that. But it had other issues. A little bit of the history of the radio. It had a burnt out 6H6 detector tube. The eye tube is weak and needs to be replaced. I got one, but I haven't put it in yet. I'm using a weak one while I diagnose it. Of course, the electrolytics were shot and the capacitors were shot. It had about a ½ inch of dust on top of the entire chassis. And of course, you know, mouse issues. So there's a little bit of mouse urine stains on the chassis after I cleaned the dust off, but it's not really bad. Actually, it's pretty clean now. But it has some issues. Right now I have just a wire running as an antenna to give you an idea of what's going on. So let's begin. I'm going to go ahead and plug the unit in. And I got it somewhere near my local station, and unfortunately I'm going to have to reach in and out of in front of the camera here to do this. So let's see, okay. This is the volume control here. This is the channel selector. This one is the band selector, and this is the tone, on, off, and tone. So that's the 4 controls. It has a fine tuning and a regular tuning. We'll give it a second to warm up. Speakers over on the left in a box for its protection. And I'm going to go ahead and get it on the station here. Okay. That's our local station here in town, and I can't leave the volume on there, but you get the idea. It sounds good. However, you can see the music up on the scope. I assume you can see that. Yeah, you can see it bouncing around there, and I can zoom in later. What you're seeing there is half of the detector. So right now I'm on the negative half of the detector tube with my oscilloscope here. And you can see a nice clean, again, if I zoomed in there, you'd see a nice clean IF signal and a really nice audio component on that IF signal bouncing up and down there. There's no distortion. It's crystal clear. The frequency is great. There's no pits, no spikes, nothing out of the ordinary. I mean, perfect AM signal. Turn the volume up. And here's the tone. You see the bass works. Okay, so we're going to leave the volume. Okay, now you're beginning to see part of the problem. Look at the signal now. It completely dropped. It's still there, but it's distorted, or it's totally gone, one or the other. If I switch to band switch and come back a couple times, it'll usually come back. There it is. But notice the decline in the volume on the scope. You see how much it's dropped? Now watch, it'll come back up on its own, which is like an AFC, right? Automatic frequency control is funky or something. But that's not the problem. I mean, that's a side effect of the problem. Okay, so now I turn the signal, the volume back down. You did notice one thing, when I turn the volume up, okay, it motorboards and distorts. I turn the volume back down, it's a low signal, it'll build back up. That is the automatic frequency control, because when it distorts, it sends a high voltage to the 6H6 tube, which also controls the AFC, and so it drops the voltage down. It's supposed to do that. And then the voltage comes back up as though it was a weak station. When I turn the volume down, you know, there's less volume, less noise. It doesn't see it as an extra strong station. It sees it as now a different station that's weaker, so the volume comes back up, and that's what you're seeing on the scope. All good and fine, right? However, there are other issues besides the motorboating. Now, the motorboating I can fix. You know, it's a common problem. Usually has to do with the impedance of the power transformer. Sometimes it has to do with bad shielding. Again, there was a lot of dust on this. Other times it has to do with the wires are not laid right. The way the wires are laid out are not correct. And they can oscillate, cause distortion and motorboating. On this radio, what I've ruled out so far is moving the wires. Does absolutely nothing. Actually, when it's playing, you can see it's fine. So moving the wires is no problem there. The power supply capacitors are not the problem. I moved them and rearranged them. I even took the power resistor down to the chassis on the transformer side and got it away from where it originally was, which is right at the tuning, right? So that means more likely than not, it's the impedance of the transformer. Or what would mess up the impedance of the transformer? Unfortunately, the schematic does not give the impedance of the transformer on any of the windings. It does give the voltage to the rectifier tube, which is the 80. And we will look at that right now. And I assume you can see that digital meter. Yes. I'm going to set it to DC. It's already grounded here. Got a probe here. If we look at the high voltage on the rectifier tube here, get on the right pin. Yeah. You see it's 340 volts. Okay, give or take, 343. On the other side of the filament, same thing, 343 volts DC. It's supposed to be 375. However, I'm running at 110 volts, not 120. If I kick it up to 120, the voltage will be fine. I have actually checked that voltage with my scope using, I have a times 100 probe, so I'm able to check high voltage without hurting my scope. And I checked it, and it was pure DC. The ripple was, it wasn't there. It wasn't even registering on the scope. This schematic uses two 40 microfarad, I believe they're 40 microfarad. It's been a while since I recapped the power supply. Let me check. Before I tell you wrong. Yeah, 245 225 microfarad capacitors in parallel. So I got those. So that's the equivalent of a 50 microfarad capacitor. The second capacitor is a 16 microfarad, which is on the other side. It's this one here. It's on the other side of the field coil for the speaker. So these two are in parallel. They're on the primary side of the speaker field coil, or the input of the field coil. And this one is on the secondary, or the output of the field coil. It's actually not a secondary, it's the output of the coil, right? Because it's just a choke coil. So we've got that, and the voltages seem fine here too. If I check the voltage here, you see we got 250 volts here, which is fine. Again, it should be a little bit higher. Let me get my paper out from underneath this meter. Okay, this is the tube layout of the radio. And I actually drew out the tube elements so that I could keep track of checking voltages. There's two 6V6s, they're up behind this output transformer here. On those, we're supposed to have 249 on the plate, 250 on the screen, on both of them. 244 on the plate, 250 on the screen. What I measured was 258 on the plate and 261 on the screen. So the voltages are about 12 to 14 volts higher than they're supposed to be. That's at 120 volts, and I didn't leave it there long because the radio is rated at 80 watts, and at 120 volts, it's drawing 89 watts. So that's not good. Again, pointing to the possible problem with a transformer or a problem in the circuit, right? But all the caps have been redone. Okay, on the 6F5, which is this tube here, behind there, that's preamp. We're supposed to have 100 volts on the plate. Again, we got 123, so it's high. And all of the voltages are high except for some. There's a tie point on pin 6, which is supposed to have 220 volts, and it's just a tie point that goes to the other tubes. It's got 245, so it's 25 volts high. So these voltages are high at 120 volts. Well, that means that the transformer is putting out a higher voltage than it's supposed to, which doesn't make much sense because the rectifier is right. However, let's not worry about that. That's not a big percentage, right? We're looking at about 10%, maybe 20% on this one, 23%. But these are about 15%, and schematics are normally plus or minus 20% on the voltages, but they are high. The cathodes are supposed to have 13.8 volts on the output tubes, again 14.8 volts. This one got 15 volts. So what's in parentheses is measured. I don't know if you can see that, but I'm just pointing it to you for reference. This is the 6H6 that was burnt out. All it is, of course, is dual diodes, right? Because it's a detector. Right now, currently, while I was working on it, to make it more efficient and to keep the voltages down some, I took the 6H6 out and I put in two Schottky diodes, which are solid-state diodes, right? They're more efficient. You don't need the filament. So that keeps the current rating down, which is what I wanted to do while I'm working on it. I don't want it running high. But even with the Schottky diodes, at 120 volts, it's drawing 89 amps. 89 watts, and it's only supposed to run around 80 watts. So if I put the 6H6 in there, it's got another double draw on two filament heaters, right? Which will drive the current up even more. So we don't want to do that. So until I, work on setting voltages. But I'm not really worried about that. Okay, now continuing the deal, I recapped it. I've been over these caps a number of times. They're exactly what they're supposed to be according to the schematic. It's obvious, right? You can make a mistake. You're supposed to put in a .004 microfarad, and you put in a .04 microfarad. You're off by a factor of 10, right? So it can happen, and it does happen. And I've made that mistake. Everybody makes that mistake once in a while, but I went through and verified them all. Okay. I did find an error on the schematic between the schematic and the wiring diagram, which we can look at too. Okay, so right now, like I said, if you look at the scope, you'll see that we have a nice clean signal. It's playing fine.
Ingredients, relaxing all-time favorites. The new 1077, The Breeze.
Okay, and that's my local Cornelia, Georgia station. Playing fine, right? And I can turn the volume up, it'll stop motorboating or squealing, which is similar problems. Okay, so if I look at the voltages, I already checked some, but we just checked the output there, and we checked, well, here's the main filtering capacitor. We got 342 volts at 110 volt input. So that's good. That's fine. These voltages are not high at 120 volts. I mean, they're plus or minus 5%. So they're fine. So it's not a voltage problem from the 80 rectifier or the filter capacitors. They're brand new, and they're IC capacitors. I only use Illinois capacitors or Panasonic. I mean, I use the best capacitors you can get at Mauser.com. I don't buy all of these. Almost every single one of these, except for this one, I believe, is an IC capacitor. They're all Illinois capacitor. Oh, that one's not Illinois either. But those are higher values, and that one's in the output. This one is going to ground. It's just, they're not a problem. They check fine. They're brand new. But other than that, I use all ICs, and I can replace those with ICs. It won't make any difference. In fact, this one I had an electrolytic in here. Long story. And we can look at it when we get to the schematic. There were two micas here that were out of tolerance. Since they're on the amplifier stage, I just went ahead and put some film capacitors in there that are exact, rated at 1,000 volts. So, the originals were rated at 400 volts or something like that. And they're fine, So those were replaced. The others seem okay. I checked them. I didn't check every single one, but these are on a set. There's a control here on the side. When you're going to do an alignment, you set it to set, and it uses these two capacitors here to ground. And you set the IF, and then once you get the IF set, you turn this switch to operate. It just says set and operate. And then those are no longer in circuit. So they're not in circuit. Well, doesn't matter whether I'm in set or operate. They're fine. They're doing the same. Now, here's the problem. I'm going to tune up the dial. Okay, so we're going off. We're going toward this station that we were listening to is 1450. We're going to go down to around 600 to the low end of the dial. I'm going to turn this up to right before boats. Okay, right there. Now I'm going to back this up, make sure we still got that a signal, and we do. So now we're going down the dial. Once I get to around 800, which I'll tell you roughly, okay, pretty soon, we're around 1,000 hertz. Come down, get into the low end of the dial, and we get that, okay? And it's intermittent, and look at the delay. Now, if I keep going, I get that, and then it goes away. Now, it's gone. If I wait, it'll actually, the automatic frequency control, turn that down, it lets go, okay? And you hear that? And listen. And it'll keep doing that. That's the weirdest oscillation I've ever heard in a radio. Oh, there it goes. Now you hear the reception trying to come in? Yeah, here it's trying to receive. Now look, motorboating. No, that ain't even motorboating. That's that distortion. And if I leave it alone, distortion. Receiving, distortion. Then it goes dead. Radio's dead. Okay, that's the bottom of the dial. So from the bottom of the dial on, it goes dead. Okay, now you all know if you will work on the radio regularly. Oops, I just knocked off my detector. Hold on, I just had it tacked on. Let me tack that back on. I'll be right back. Okay, sorry about that. Like I said, I just got those Schottky diodes tacked in because I'm just using them temporarily. So a little bit of solder squirt I got on the chassis there. Okay, a lot of you know this trick of turning another radio on to check the oscillator. So if I put this on the low end of the dial, there's a station about 30 miles from me, if I can get it. Okay, there it is. Okay, you can hear that. Now, if I tune by it.
Can you name all of your grandparents? Parents? Can you? Interesting. Have you never thought of that? Those I can name. I can name maybe one or two
There it is.
great grandparents.
Here how it drops, high there, low,
I can probably
high,
find them. I've done a little
low.
research. I might be able to find some of my,
Hear that?
my papers. I'll have to, now I'm gonna April is a great time to contact
There you go.
Division of Life Spring and now located
So the oscillator in the radio is working because it's detuning this radio, right? So it is working. The oscillator is working, but I'm getting no signal. In fact, I'm right on that same station. I should have a signal up on the scope, right? I should have the station. I'll have nothing but that crazy static and dead air. You can hear the dead air. And a hum. Now the hum is from the probe, most likely. No, not the probe. Well, anyway, sometimes I get rid of that hum by, yeah, see the probe is inducing some of the hum. That's a hot, so the hum is coming from, I've got LED lights, I got power lines over me, and this thing, which is an LED, it's not doing nothing now, but, so, you know, that's where the hum's coming from. When I'm up in where it actually receives, there's no hum. So it's picking up noise, but it's not picking up the stations, and it's doing that crazy. See, the hum's gone there. Right there's hum. A little farther, it's gone. So it's picking up noise, but it's not picking up the station, which makes no sense. And I can't get any of the lower stations. However, if I tune the IF, and I connect the IF up for my signal generator at 455 kilohertz, and I go to the low end of the dial, I'll get the IF signal, and of course can do an IF alignment at that time. But that's, connecting directly to it. And this intermittent stuff that comes and goes, hear that? It's sort of like motorboating, but it's really not motorboating. It's interference. It's something coming up and down, and it's almost like a capacitor charging up and then discharging. But that's not the problem, because the capacitors are all brand new, and when I put it on a high end of the band, it don't do that. Again, I moved all the wires. I mean, that's pulsating more than motorboating. Motorboating is, that put. Well, it's this. That's motorboating. Squealing and putting. This is in the tuning section. On the low end of the dial, that's motorboating. That putting sounds like a boat motor. On the high end of the dial, rather, I don't get anything but my local station. So I get one station, that's it. But when I'm on it, and when it's coming in fine. Okay. And this is another issue. Like right now, it's not playing. It's not coming in, it's not on the scope. If I switch this back and forth, can't see the dial, unfortunately. Let me turn it a little. Oh, I'm away from it. There it is. Now watch. It's distorted as anything. And now look, it's clearing up. Getting loud. I should have had this connected. And there it is on the scope, nice and clear again. You see how slow it comes up? And there are other times it'll go away like that and I can't get it back for a while, then it comes back. Strange. Okay, there's another strange issue. You probably already noticed a couple things. One, you probably noticed that this wire is not connected. That don't matter, that's the phono. I disconnected it to rule it out. It just connects to the detector. No, it connects to the volume control. So it's disconnected. So it has no effect, no bearing on anything at all. But what you probably also noticed is a lot of new resistors. Usually you change a resistor or two, if there's a problem. Turn the volume down, you can see it on the scope anyway. If you, recap a radio and you're checking the resistors as you go along, you might find a resistor or two that are out of tolerance. The resistors in this radio were all bad. Every one of them was over 20% out of tolerance, and they were all rated 10%, silver band. They were all 10% resistors, plus or minus 10%, and they were over 20%, some of them way out of tolerance. Now, somebody had replaced this resistor down here, which is in the power supply. It's a wire round. It looks like it's probably a 10 watt. I would have said 7 or 8, but it's probably a 10 watt. If it's a 10 watt, it's still too weak. It needs to be at least 11 watts, judging by the current going through it. So I would have put a 15 watt. somebody replaced an original wire wound. Now that was directly connected to this capacitor here, so it was in this circuit. Since they put this wire wound in there, I was like, well, maybe it's wire wound, it's a coil, it might be sending out a magnetic field that's interfering with the magnetic field of these coils and causing that problem. So I was diagnosing it with it up there. So I took that and ran a wire down and put it down here on this strip. It's just tacked in because I'm going to put a better one in there. Anyway, and then in the process, I ran some other wires. There was a big old bundle of wires that connected to this capacitor. Again, dress leads, right, can cause motorboating and distortion. So I ran new wires down, and that's what these pink lines are. They're connecting to the new wires, and they run along the chassis and down and connect to the resistor down here, which connects to that capacitor, which I left in the same place because it's on a tie strip. Not only that, if anyone else works on this radio, I want them to be able to understand what's going on, why it's not exactly like the wire diagram. And they would see that. They would see that this is that capacitor. It's always been there. So by putting it here, it's fine. It's DC, right? So it doesn't. It's not the problem. And there was a big old bundle here. When I moved that whole bundle down here, including that resistor, it really didn't clean anything up. Even though I redressed all the wires and everything, it didn't clean up the noise. Has nothing to do with that. It's in this circuit here. Now, something is it's like a capacitor that's being charged. It's not supposed to be charged. It's holding a charge, and when you flip this back and forth, it discharges it or something, and then the automatic frequency control clicks in, and it starts real low, and then it slowly comes back up. I can let it play like this, and it'll play for a long time, and then all of a sudden, it'll go. And that signal it won't do any kind of weird noise, but the signal will drop to nothing, almost nothing. And then it'll slowly come back up. So it's parasitic oscillations that are causing a problem. The other thing I noticed is that when it is playing, it's hard to do because YouTube and their crazy copyright laws, right? You can't get anything on without getting in trouble for playing copyrighted music. I mean, I'm just trying to test the radio. But you see the signal jump there? Look, that's me touching the IF transformer grid, IF2 amplifier grid. Sometimes when I move that wire, like if I get it to go off, okay, that might have did it. No, it came right back. Sometimes that'll mess it up. Or it won't play at all. Did you see how high it went just a second ago? Look at that. That's much higher voltage. That's better than it's been since we started. And now it's lower. That's just me touching it. Look at that. Look how low it is. And I'm just touching the grid cap. Look, so there's a problem. Turn that back down. There's a problem not only with isolation, but there's a problem, with oscillation in the oscillator circuit area, but the oscillator is running. There's also a problem in the IF area, okay? So touching this, that should never do that. That's the best signal this radio ever has, which is excellent, but it should never do that. When I touch that, it should go to nothing because I'm grounding it out. I'm becoming an antenna, right? And when I let it go, it should go right back to where it was. It shouldn't go back to like that, half voltage. So there's a problem in the IF cans. All right, so we got a problem in the oscillator cans. We got a problem in the IF cans. We got high voltage. We got motorboating, and we got squealing. All of those are different issues from the problem. The other thing that happens sometimes is when I get that crazy squealing. Look, there it is. Now notice, look at that. It's pure RF, radio frequency with an oscillating, probably 120 hertz signal in it. That's the noise, the squeal that you can't handle listening to. Look how high that is in volume. And there it's dead. Just that little bit of a change from there to there. It goes into serious oscillation. And yet it looks like there's some kind of signal riding on it. That may be line signal, but I don't think so. Now sometimes when that happens, and I come back up here, and of course I don't want to play at that point, right there. See how weak it is? No, it'll come up on its own, but sometimes it won't. And if I go to the grid of the mixer here and move the cap around, sometimes that'll make it come up. Another thing that always makes it come up, and this is interesting, is if I go here and I measure voltage and I touch the grid of that tube. If it well, not on DC. If it was totally dead, like it was earlier, and I had to keep switching it. Am I touching the grid? No. So it's -7 volts on the grid, which is fine. But now it's playing, right? But it's playing at a much lower volume. I may not be right on the station. Nope, that ain't the problem. Oh, yeah, it might be. Sorry about that. Yeah, that was me. Oh, look at now it's playing really good again. But again, that's just my local station. So we got all these issues. Bad resistors, which we shouldn't have bad resistors. Oscillations that can't be controlled. Oh, something else. This is the high frequency end of the band. Adjust. These work fine. I can tune the high frequency to get it right on the spot. In fact, I did. This station is 1450. I got it tuned so it's right on the 1450 on the dial where it belongs. The low one is right in there. It's one of these. It's in there. It does nothing. Absolutely nothing. I checked everything that connects to it. It's all working fine. But that control is not working. Of course, that's where the oscillation is, right, on the low end of the band. So, of course, it ain't going to do anything because there's a problem. So we got an oscillation problem, bad resistors, high voltage. My conclusion is for all the resistors to be bad, something burnt out. Somebody kept playing the radio with distortion, or they weren't there and they had it on. It was probably motorboating like bananas, and something shorted, probably that detector tube, who knows, or the capacitors, a couple of them might have just shorted completely out. The electrolytics were changed at some point, so somebody changed them. Before they changed them, they probably shorted. They took out all of the resistors. If they took out all the resistors, they would have overheated the entire unit. That would have overheated the output transformer. It would have overheated the power transformer. They could be have windings that are shorted. There's no resistance measurements on the schematic of what they're supposed to be, so I have no way of knowing if they're right. However, the voltage is right, but that doesn't mean nothing. Having the voltage right without a load is one thing. Having the voltage right with the load is something else. If I put this on here and measure that high voltage, there, so we got 341 volts, and I turn this up, the voltage drops when it motorboats. So under a higher load, this transformer is dropping out. That squealing could be this transformer. It is pitted, but I don't know what that is. It's some kind of wax. It's not wax. Well, maybe it is wax. It's black. It's something coating they put over the coil, which is really strange. I don't know why they did that. Anyway, this one could be causing some of the squealing. After all, that goes directly to the speakers, right off the high end. The motorboating could be this one. Um, it could be a weak tube. Every tube tests good except the two that I had to replace. Every tube tested good in the circuit. The two that were bad was the 6H6, which was a detector diode, and the beam, the magic eye. Well, that don't matter. You don't even need that, right? So, in fact, a lot of the times I didn't even have it plugged in while I was checking things, and same thing. But I put it in because I wanted to check more current draw and to see what it was doing to the current. So I put it in, same thing. When it was there, same thing. It's not dead, it's just weak. It just doesn't have a very good glow. So it's really not bad, it's just weak. The 6H6, I got a brand new one. I put it in there, same thing. So it's not the tube. I went back to I took the diodes out. I ordered the 6H6, I didn't have an extra one. I put the diodes in, did my recap and testing. It came in, I put it in, took the diodes out. It was worse, of course, because the diodes are much more efficient than the tube. But it was still fine. I mean, it was just a little bit worse, not much worse, but a noticeable amount. So to diagnose it and keep the current draw down so I don't hurt anything, I took it out, put the Schottky diodes back in. And because it's just detecting, right? That's all that does. That's half of the wave. The top half is exactly the same going up and down on the top, the other way. You have to have a detector, right? Because they're out of phase. So if you didn't have a detector, they add up, and when you add up opposite signals, you get 0 volts, so there'd be no sound. So you have a detector in the radio, which gets rid of half. Well, you see, it's getting rid of half. All I got is the bottom half. And that half is what's sent to the speaker, and that's what you want, right? So the diodes are working really efficient. There's no distortion in there at all. Everything's great. I'm thinking this radio got hot at some point. I'm thinking every single resistor got toasted, got really hot, and thrown out of tolerance. I replaced them all with new resistors. A lot of times I went up in wattage. Instead of like I put a couple 1 watts in here, I got all half watts, and I do have a couple wire wound 2 watts up there in the power stage, but they don't matter. They're up there. They're nowhere near the oscillation issue. I did backtrack stage by stage, taking out each tube, going back until I found the stage with the oscillation, and I took out every single tube. So the oscillation is in the antenna side, in the oscillator coil side. I'm totally lost. I have no idea what's causing this issue. There's nothing in here that should be bad, that should do that. So the only possible conclusion I can come to is that the coils got overheated. Now these coils wouldn't be a problem. This coil looks pretty funky, but he's on the high frequency band, this shortwave band. So he has nothing to do with AM. And he's working. There's resistance across it, and 6 volts actually connects to the pilot light. So, and it goes to ground. So it's doing its thing. This crazy RC circuit, who knows? I think it's dead. But it don't matter again because that's high frequency, right? So that would have nothing to do with the AM band. And I jumped across it with a capacitor and a resistor and nothing. It's no difference. So that ain't the problem. The IF cans, possibly. They are tuning. I was able to tune them. The antenna trap, no effect. You can turn this from one side to the other and there's no effect. However, it's not shorted. So again, that would be, you would do that more on the low end of the dial. Well, the low end of the dial is dead. what else can I tell you that I did? I checked the tuning capacitor, because again, right, there was a lot of dirt in on this chassis. There was dust built up beyond belief, so there was quite a bit in there. Let me go ahead and unplug it, shut it off, and get this out of the way. We'll take a quick look at the top. Oh, by the way, this transformer is held in by these clips that are folded over, okay? And so, you know, it drops out now because I got these pried shut. That was so I could recap behind it. I didn't want to bend them back and forth, so I put this little clip on there, which is just holding that there. I made sure that this was grounded. I ran a ground strap to it and no effect, so it's not like that's not grounded. That has nothing to do with it. The iron core, if I ground the iron core, there's no change. So it's not, that has nothing to do with anything. But that's just so I don't break those tabs off, bending them back and forth. This is where the 6H6 would go. Okay, can you see yeah, you can see in there. Shine a light down in there. You see that tuning condenser is really clean. Let's see if I can get it where you can see. There, it's a little better behind those tubes. It's not that hot. I'll take it out. That's the audio preamp. And you see it's really clean. I cleaned it really well. I went over it with a magnifying glass. I was looking for, you know, tin whiskers or something. Who knows? Anything, right? That might be short, might be touching. When I tune down the band, they're not touching. I shorted each one to the stator one by one and heard noise. So they were not shorted. If they were shorted, it wouldn't have made any change at all. So they were not shorted. None of them are shorted to the stator. Everything's fine. I tried moving the outside ones out a little to see if that would quiet down the oscillation. No effect. Checked the ground, made sure the ground was good. The ground's fine. Checked the brushes here that go to the top section from ground. They're all fine. The ends are cleaned. There's no problem there. When I did start the IF tune process, this is the primary, this is secondary, primary, secondary, IF1, IF2, IF1 of course, because it's got the wire going to the IF amplifier. I did one, it said in the instructions, do 1, 2, 1, 2, and that's all. You don't need to go back and keep doing them. Well, I did 1, 2, 1, 2, and the problem was there. I came back and fine-tuned them. You shouldn't even have to do. Still no problem. There is a hole here where it looks like there was a screw, but that screw does nothing. I don't know what it does in the can, but it doesn't do nothing. It'll unscrew and come out, so maybe it holds something in there. That screw is missing. That's a possible issue. It could be causing a problem, but I see more response here than I do there, moving this around, this wire and all. So I don't know. I could pull these cans apart and check them out. That would, you know, if it was just an IF issue, I would do that. Now, if this radio was a mid-century modern rather than an antique, if it's 50s, 60s, I would think, possibly SMD, right? Silver mica disease on the capacitors in these cans, because that causes squealing like that. But this is an antique radio. While it does have mica and it does have silver plates, they're not silver-coated mica plates. So you don't have that SMD traditionally. It is possible. And if all this had was an IF problem, yeah, I would check those. This one could be an issue. I don't know. I'd have to pull that can off. All right, back up. I set 1, I set 2, primary, secondary. I went to can 2, primary. When I went to secondary, the screw was really tight, you know, and that happens, right? They sit for a long time, they get tight, you got to break them free. Well, it's not tight at all now, and it is working. I mean, I just threw it off, but I know about where it is, and I can retune it. It is working. It's tuning. There's nothing wrong with the capacitor. Actually, all 4 capacitors work fine. I can set the IF right on peak. Okay, so the capacitors are fine. Now, if it was mica disease, the capacitors would not be fine. It would. That's what the mica is, right? It's a capacitor. So it would be if one of the capacitors were bad, I'd know it. I don't like that, but I don't think it's a showstopper. Again, if it was just IF, I would have pulled these apart and checked them. But it's not just IF. It's motorboating. It's the low end part of the band, which is a bigger issue. It's the oscillation that makes no sense at all, that comes and goes. It's even the good channels on the high end playing fine, no distortion. The IF's working perfect, and then all of a sudden the volume drops, and then the volume comes back up. What I'm going to do is set this unit aside. I've got a backlog of projects, and get on to another project and come back to it. But if anyone watching this video has any ideas of what I should check, aside from these IF cans, and I will do that, please leave a comment, let me know, and I'll take your advice and do some more testing. I wish I had another chassis like this to compare with, but I don't. Set, operate, there's the two controls I was talking about. It doesn't really seem to have any effect one way or the other, but I did what it said to do in the alignment. So, and that's my antenna. I tried grounding this to a water pipe, no change, so that was not a problem. Okay. So anyway, let me show you, this video is getting long, and I apologize for that, but let me show you the schematic diagram here. Show you, okay, there's tubes. These are all the tubes, so I know the pin layouts of every tube. Here's the wiring diagram, which shows you exactly where all of the wires go, what all the capacitors are, where they're at, what resistors, where all the resistors are. Here's that funky RC unit that I pointed out that is kind of iffy, but that's not the problem. That it might make some noise or whatever, but it's not going to stop the radio from playing. And I jumped over it. So the original capacitor in the middle of the chassis, where'd it go? It's right here. And you see everything connected to it. This is that big power resistor that I moved to the base, to the chassis to get it out. Because, the coils are right here, right? Here's all the coils. It's right next to them. So I moved over half of this down to the chassis to make sure it wasn't oscillating into here, into these coils, causing some problems. Nope, not a problem. That's not the issue. There was, like I said, I did find an error here. If you look at this dual capacitor, there's two capacitors and one wax capacitor, which I replaced. It shows this one, C32, coming around, going to pin 6 of the audio amplifier tube. Okay, according to the schematic diagram, on the audio amplifier tube here, what was that, C32? Yeah, C32. C32 is not here. What is here is C35, which I believe is the other one. Yeah, C35. So on the schematic, they're showing this C35 being this one that goes to pin 6. And they're showing C32 going to the 6C5 over here. I believe it's pin 8, cathode. So if I go to the schematic, 6C5 inverter here, and C32 right there. 12 microfarad electrolytic going to the cathode, right? So what I tried to do first And up here, this is C35. It's a 1 microfarad. So what I did is I put an electrolytic in here. Now, it had been replaced with an electrolytic, so I don't know originally what was there. But I'm assuming 1 microfarad, back then, in those days, probably not. It would have been an electrolytic. So I put an electrolytic and actually put a 4.7 to give me some extra headroom. And that made no effect. And here I put in a 12 microfarad, made no effect. So the schematic has a 1 here and a 12 here. The wiring diagram from the same place, Stromberg Carlson, their engineering wire diagram shows a 1 on the C on the 6C5 and shows a 12 here. So I tried both. I switched them around. Finally, I said, you know what? The engineers are going to put more attention in the schematic diagram than they are in a wiring diagram. Of course, that could be a problem, right? Because they would have produced the radios with the wrong capacitors in the wrong place because the assemblers are not technicians. Assemblers just solder. So they were sitting in the factory soldering by the wiring diagram, and the schematic diagram says just the opposite. So, there was that problem. But ultimately, what I ended up going with was the schematic, because that's what you do. You bring it to the schematic, the engineer's drawing, not the assembler's drawing. And so I put it to the engineer's drawing. And since it's a 1 microfarad, and I was like, well, it doesn't really matter if it's electrolytic or not. I've tried both. It didn't make any difference. So I put a 1 microfarad capacitor in here, non-polarized. Here I have a 12 microfarad electrolytic, because of course 12 microfarad has to be electrolytic. They don't make any capacitors that high. So I got a 12 microfarad there, and that seems right. That seems like what it should be, because this is over a 6800 ohm resistor, right, in parallel with it. So this is a RC tank circuit, and that makes sense. And it is going to be electrolytic because it's on ground, and you want to keep this positive from ground. So you want electrolytic to do that, right? A polarized capacitor to keep this positive. I mean, a regular capacitor would work, but not, like I said, you can't get a 12 microfarad. Here, it's still the cathode bypass like it is here, but it goes to a 47K, and then all the way down to, it goes to the target, and it connects to B minus. So, a 1 microfarad is fine for that, right? That's a preamp. It don't need it. This is an inverter. Having a higher bypass makes sense. You want to keep this elevated so that you have a better clean inverted signal. And we've seen the signal is perfect, so there's not a problem, because this is push-pull, right? This is two 6v6s. So you want a clean circuit. They can't be in phase because they would cancel each other out, so you have to invert one of them so that it's the opposite. So when this one's going up, this one's going down, and when this one's going up, this one's going down. And so that's push-pull, right? They're going, flipping back and forth and using different halves of the coil. So you always have, this is the output transformer, that big one that I had to bend the tab on that connects to the speaker. That seems to be working fine. But you notice they don't give you any resistance values on that. Now, they did give us the resistance value on the field coil. It's supposed to be 1050. I've got 980. So that's perfect. I mean, it's within 10%. So that's fine. The field coil is fine. The speaker's working fine. The speaker, they don't tell you the speaker either, I don't think. Oh, yeah, they do, 1.5 ohm. But the speaker works fine. You heard it. Sounds great. So the output transformer is working fine at the frequency of our local radio station. But once you get down to the low end, who knows what's happening there, right? If it's got some shorted coils, they would affect the higher frequencies, the lower frequencies, because they're directly related. And so all the capacitors are changed, all the resistors are changed. The issue has to be here because when I pull out this tube, the distortion stops. I put this tube in, the distortion's there. Well, everything stops. You pull this one out, right? There's no sound. But looking at it on the scope, there's still distortion. There's distortions here. So I took this tube out. I took this tube out. I backed up, and all the way up to here, I got distortion. Actually, I wasn't getting much of a signal here, but that's to be expected, right? That's the low end of the amplifier. So it comes from the antenna. It's very weak. The oscillator's working. We found that out with the transistor radio and the fact that I can pull in my local station. So the oscillator circuit's working. The antenna circuit is providing a signal. It's on the same band. I'm not changing the band, so it's getting the signal. And the oscillator's working, which is adding to the radio station that we're tuning to. The tuning condenser's working on the high end of the band, but on the low end it drops off. So I don't know. I mean, it could be inductive, right? It could be in here that there's a problem on the low end. Now all we're using is 2 of these, right? Because we're using the AM band, we're not using the sideband, we're on AM. So we're using 2 of these, and I believe that was these 2. Yeah, it was these 2. C5 and, yeah. Anyway, it was these 2. We're using this section for AM. And so I don't know. I don't know where it's coming from. I don't know why. And if it was just that, just the low end, I would think tuning condenser. But it's not just the low end. There are other stations up near my local station on the high end of the band that I don't get. I don't even get any sound like it's trying to receive up there. I get nothing, even on the high end of the band. So it's the whole band. It's not just the AM, the low end that has all the noise and distortion. The high end's dead, other than my local station. Now that could be just super quiet, but I doubt it in this radio. So that's what we got. And everything in the wiring diagram has been gone over time and time again. I mean, I even found that error. I made sure that everything was right. This is the phono in the phono section, which we don't have a phonograph. This is the cable that I got, where is it? Somewhere up here. Here, this is the cable for that comes out the back of the radio that I got disconnected. It's not being used, that's it there. So it's disconnected, and it went to the volume control. And the volume control is working fine, other than the distortion at the high end. Now the other weird thing is it had this bias cell. I've never seen one of those before, but I did read up on it, and basically it's an old battery, right? It's a little battery that they had in there to bias this grid. Well, they said to use a watch battery or anything today would take care of that. Well, I did. I used the battery. Didn't make any difference at all. So even though the old one is shot, I went ahead and biased it with low voltage battery, a 1.5 volt battery, bias this. The grid voltage is perfect, so that it makes no difference. And if it made a difference on biasing the grid, it would make a difference on every frequency, including my local radio station. So, no, it's not an issue, and I don't know why they even used it. They never used them in any antique radio, but they put it in this one. I guess, they wanted to make sure that at 120 volts that this thing stayed slightly positive to the cathode, but it is. So, it's not a problem. The cathode's at ground. It's directly grounded. And like I said, I tried that. That's not the problem. If it was a problem with anything, it'd be the problem with the motorboating, not a problem with anything else. Not the squealing and all of that. That would have nothing to do with that, because it's just battery. It's not a dead connection, it's just a voltage supply. So that has nothing to do with anything. And if you short that capacitor out, you lose the signal. So if it was shorted, it wouldn't do nothing. If it was dead, it would still work. So that's not it. Anyway, if you guys have any idea, I appreciate some feedback. I'm sure it's probably mechanical, being, the output transformer, power supply may be weak, and that's causing the motorboating because the impedance is messed up. That would make sense. You draw more voltage. Oh, this is that power resistor. One last thing. This is the one I moved down to the chassis. You notice it's a 25,000 ohm. What they replaced it with, when they replaced it, I didn't do it, they put a 20,000 ohm. Well, I jump it in a 30,000 ohm to see what difference it would make if we went up instead of down. And what it did is it made the current go up, it made the voltages go up, which is what I expected. So the 20,000 ohm they put in there is better than the 25,000 ohm as far as keeping voltages down. However, I tried a 25,000 ohm, it had no effect. The voltages are fine, they're actually high. So the 20,000 instead of 25 is helping the problem. But it shouldn't be a 20,000. It should be a 25,000, and there should be no problem. Well, again, that leads back to the power transformer, right? Because that's directly across the output of the high voltage, the B plus. That's straight across the B plus. The only thing the B plus goes through is the rectifier tube, through the on-off switch, through the field coil, which for DC is a straight, it's just 1,000 ohms, right? 1,050 ohms. And then it goes directly across that to ground to the other side of the coil. So that is directly across the transformer. I mean, you could add 1,050 and it would be 2,650 across the transformer. So the fact that 2150 across the transformer is dropping the voltage is not a good sign for this transformer. All the resistors being bad, this transformer seeming weak. This transformer being weak would fluctuate if the impedance is bad. It would fluctuate over this rectifier. It would cause the motorboating when you turn the volume up. Because you turn the volume up, you're dropping the resistance on the B plus, drawing more current out of here through the circuit, and a lot more current than it's supposed to be. That's going to pull this voltage down on here. And we looked at that and we seen that it does. When it's motorboating, the voltage of B plus drops. The longer you let a motorboat, the more the B plus drops. The higher the current draw on this secondary of the transformer output here. Thanks for watching. I'm sorry this video is long, but I wanted to be thorough because if somebody has an idea, they can at least know what I ruled out and go from there. Thank you and have a great day.